So in today's video we will be learning different laws of chemical combinations. So first of all, various chemical reactions take place on the basis of certain laws which are called as laws of chemical combination. So in this we will be studying 5 laws. The first law is law of conservation of mass. It was proposed by Lavoisier and it was verified by Landolt. So, what does this law explain? It states that matter can neither be created nor destroyed in the course of a chemical reaction. Matter can neither be created nor destroyed. But the matter can change from one form to another form. The total mass of a material after a chemical reaction is same as the total mass of the material before a chemical reaction. So this is law of conservation of mass. Now we will be studying the law of constant or definite proportion. So it was proposed by Proust. Hence this law is also called as Proust's law. So what does this law state? That in any pure compound always it contains same elements combined together in the fixed ratios of their weights. Whatever the method of preparation it may be. So this is the statement given for this law. So we will understand this statement through an example. So they are asking us to take any pure compound. Let us take carbon dioxide. And what does it contain? Carbon and oxygen. So if we take any compound of carbon dioxide, only these two elements will be combined together. Only the carbon and oxygen will combine together in the fixed ratios of their weights. If we will take 1 gram of carbon dioxide also, we will find same ratio of, will be in 1 gram of carbon dioxide and 16 grams of carbon dioxide. The ratio between carbon and oxygen in this 1 gram as well as in this 16 grams is same. How can we prove that? See, let us calculate the total weight of carbon monoxide, total mass. Okay, so what is the mass of carbon? 12 grams per mole. What is the mass of oxygen? Atomic mass 16 grams per mole. In carbon dioxide we have 2 oxygens, so into 2, which is 32 grams per mole. What is the total mass of carbon dioxide? 12 plus 32, which is 44 grams per mole. Right. Now we have to calculate the mass of carbon in 1 gram of carbon dioxide and the mass of oxygen, the weight of oxygen in 1 gram of carbon dioxide. How do we do that? For carbon, we have to take this 12 by 24, which is 0.273 grams. So in 1 gram of carbon dioxide, we have 0.273 grams of carbon, and oxygen is 32 by 44 will be getting 0.727 grams. So in 1 gram we have 0.273 grams of carbon and 0.727 grams of oxygen. What if we take 16 grams of carbon dioxide? We have to multiply this into 16. So we will be getting here, carbon will be getting 4.4 something around, and this oxygen will be getting 11.6. Okay. So total it will be 16 grams of carbon dioxide. So here we can see that the ratios will be same. Whatever the method of preparation we take, the ratios will be fixed. So this is the second law, which is law of constant or definite proportion. So now we'll be seeing law of multiple proportion, which is the third law. So this law of multiple proportion was proposed by Dalton and it was verified by Berzelius. So what does this law state? It states that when two elements A and B, let us take A and B, they combine to form more than one compound, which is AB, AB2, AB4, okay, more than one compound. When two elements A and B, they combine to form more than one compound, the different masses, see this different masses, the different masses of one element, say B, combines with the fixed mass of another element, let us say A, okay, that are in ratios of small whole numbers. So this is the statement of law of multiple proportion. We'll understand this with an example. So what are they saying here? We'll take two elements. Let us take carbon and oxygen, and they combine to form more than one compound. So what this carbon and oxygen combines and gives? Carbon monoxide, first compound, or carbon dioxide. Okay, so let us think this AB, AB2 or AB4 as carbon monoxide and carbon dioxide. Two elements combine to give more than one compound. The different masses of one element combines with the fixed mass of another element. In carbon monoxide, one oxygen is combining with one carbon. In carbon dioxide, two oxygens is combining with one carbon. Means different masses of one element is combining with the fixed mass of another element. Right. So what happens here? We'll take this oxygen, one oxygen weight as 1.33 grams. So if one oxygen is 1.33, then two oxygen is 2.66 grams. Right. So when one carbon reacts with one oxygen, and when one carbon reacts with two oxygens, what happens? Here we have carbon monoxide and here we have carbon dioxide. This one is 1.33 is to the ratio of the masses of oxygen, 1.33 in the first case and 2.66 in the second case. So what will be the ratio? 1:2. So the different masses of one element's ratio will be in small whole numbers. So this proves law of multiple proportion. So this is the third law. Now we'll be going into the fourth law. So this law of equivalent proportion or law of reciprocal proportion, it was proposed by Richter. So what does this law state? If two different elements combine with the fixed mass of a third element, okay, if two different elements combine with the fixed mass of a third element, the ratio of their masses, these two different elements masses, the ratio of their masses in which they combine with each other will be the same or simple multiple of the ratio. So this is the statement. We'll understand this statement with an example. So first let us take two different elements, hydrogen and oxygen, and they are combining with the fixed mass of third element, which is carbon. So when carbon combines with hydrogen, we'll get CH4. Okay, CH4. Okay, let us write it in this way, CH4. And when carbon combines with oxygen, we'll be getting carbon dioxide. Okay, the compound formed is CH4 methane and CO2 carbon dioxide. The elements involved are here carbon and hydrogen, carbon and oxygen. Their masses, combining masses. Okay. So the mass of a carbon is 12. Hydrogen, we have 4 hydrogens, right? So it is 4. And again carbon 12, oxygen 2 oxygens 32. Okay, 1 into 4 4, 16 into 2 32. So what they are saying here, the ratio of their masses in which they combine with each other will be same or simple multiple of that ratio. So what will be the ratio of 4 is to 32? 1 is to 8. So that is what they are saying. If two different elements, they are combining with the fixed mass of a third element, the ratio of their masses, they will be either same or they will be the simple multiple of that ratio, that is 1 is to 8. So this is law of equivalent proportion or law of reciprocal proportion. So we have completed the fourth law. Now fifth law is Gay-Lussac's law. So this Gay-Lussac's law is also called as pressure temperature law. It is one of the fundamental gas laws in chemistry as well as physics. So what does this law state? That the pressure of a gas is directly proportional to the absolute temperature in Kelvin whose volume is held constant. So this is the statement for Gay-Lussac's law. So it describes the relationship between the pressure and temperature of a gas when the volume and the amount of gas held are constant. Okay, so we all know the ideal gas equation, PV is equal to nRT. So from this equation we can tell that pressure is directly proportional to temperature. So how will be representing this mathematically? P1 by T1 is equal to P2 by T2. Okay, so here this P is pressure of gas and T is the absolute temperature in Kelvin. So we'll solve one example. A gas whose pressure is 2 atmosphere, okay, at 300 Kelvin, what will be its pressure at let us say 450 Kelvin. Okay, so how we'll solve this? Let us take where it is, yeah, 2 atmosphere as P1 and 300 Kelvin as T1, 450 Kelvin as T2, and this pressure which we have to find out as P2. So P1 by T1 is equal to P2 by T2. 2 by 300 2 atmosphere by 300 Kelvin, which is equal to P2 by 450 Kelvin. So 15 3 sir. So final P2 is 3 atmosphere. Okay.